Important question of software engineering for RGPV exam part 2. Question 3. Explain in detail about the RAD model. The RAD, Rapid Application Development, model is an iterative and incremental software development approach that focuses on rapid prototyping and user feedback. It aims to expedite the development process and deliver functional software systems quickly. RAD emphasizes collaboration between development teams and business stakeholders, enabling faster development and validation of software requirements. Here are the key characteristics and steps involved in the RAD model. 1. Rapid prototyping. RAD begins with the creation of a prototype that demonstrates the core functionality of the software system. This prototype is developed based on initial requirements and serves as a tangible representation of the envisioned system. 2. Iterative development. RAD follows an iterative approach, where the development process is divided into multiple iterations or cycles. Each iteration involves refining the prototype based on user feedback, adding new features, and addressing any issues or changes identified during the previous iterations. 3. Active user involvement. RAD encourages active involvement of end users and stakeholders throughout the development process. Their feedback and input are crucial in shaping the system and ensuring its alignment with their needs and expectations. 4. Collaborative workshops. RAD often involves collaborative workshops and brainstorming sessions where developers, users, and other stakeholders gather to define requirements, prioritize features, and make design decisions. This promotes effective communication, knowledge sharing, and consensus building. 5. Component-based development. RAD emphasizes the use of pre-existing software components or frameworks to accelerate development. These components are selected and integrated to meet the specific requirements of the system, reducing development effort and time. 6. Time-boxed development. Each iteration in the RAD model is time-boxed, meaning that there is a fixed duration for each cycle. This time constraint encourages focused development and timely delivery of working software increments. 7. Rapid feedback and validation. User feedback is collected and incorporated into the development process at the end of each iteration. This allows for quick validation of requirements, identification of changes or additions, and alignment with user expectations. 8. Parallel development. RAD supports parallel development, where multiple components or features of the software system are developed simultaneously by different teams or developers. This approach reduces the overall development time and enables faster delivery. 9. Continuous integration and testing. Throughout the RAD process, frequent integration of developed components is performed to ensure their compatibility and proper functioning as part of the overall system. Testing is carried out in parallel with development, allowing for early detection and resolution of defects. 10. Incremental deployment. As each iteration of RAD produces a working increment, the software system can be deployed incrementally. This enables users to start benefiting from the system's functionality even before the full development is complete. The RAD model is well suited for projects with dynamic and evolving requirements, where rapid development, user involvement, and quick delivery are essential. It helps organizations reduce time to market, gather early user feedback, and adapt to changing business needs efficiently. Question 4. How is software being tested? Explain the process with a neat sketch. Software testing is a crucial process in software development that aims to identify defects, errors, and vulnerabilities in the software system. It involves executing the software under controlled conditions to evaluate its behavior, functionality, and performance. The testing process typically follows a systematic approach, consisting of several phases. Here is an overview of the software testing process with a sketch. 1. Test planning. Identify testing objectives, scope, and deliverables. Define test strategies, techniques, and methodologies. Allocate resources, establish timelines, and prioritize testing activities. 2. Test analysis and design. Analyze software requirements and design test cases. Identify test conditions, test scenarios, and expected outcomes. Create test data and define test environment and configurations. 3. Test implementation. Develop test procedures and test scripts. Execute test cases based on the design scenarios. Record actual results and compare them with expected outcomes. 4. Test execution. Execute test cases systematically. Monitor and record the actual results. Log defects and issues identified during testing. 5. Test reporting and metrics. Analyze test results and generate test reports. Document defects, their severity, and steps to reproduce. Track and measure testing progress using metrics and indicators. 6. Test closure. Evaluate test completion criteria and readiness for release. Prepare final test reports and documentation. Conduct a post-test review to capture lessons learned. Here is a sketch representing the software testing process. Test planning. V. Test analysis and design. V. Test implementation. V. Test execution. V. Test reporting and metrics. V. Test closure. In the sketch, each box represents a phase in the testing process, and the arrows indicate the flow from one phase to another. The process starts with test planning and progresses through test analysis and design, test implementation, test execution, test reporting and metrics, and finally ends with test closure. It's important to note that the sketch provides a high-level overview of the testing process, and in practice, there can be variations and additional steps depending on the specific testing methodologies, project requirements, and organizational processes. Additionally, the sketch doesn't capture the iterative and cyclical nature of testing, as testing often involves continuous refinement, retesting, and regression testing to ensure software quality.